Hey guys, happy Tuesday to you. I'm sorry I can't be in class today. If you don't see me now, it's either because I have a teacher training that I have to go to, or I'm recovering from injuries sustained from fighting my neighbor's pet emu. Either way, I'm not in class and I hope you're doing well. So let's just go through these notes and then you can start on the homework. So here we're going to talk about the shape of quadratic equations. So let's first of all talk kind of big picture about what a graph is. A graph conveys two bits of information, the x value and the corresponding y value. Now in function notation, x is the input, f of x is the output, and every single point on a graph simultaneously denotes one input and its corresponding output. So in the graph to the left, let's talk about what f of 1 is. Let me get something here where I can mark this up. And here, f of 1. So f of 1 means the y value when x is 1. So x is 1 right here. We're going to go down, 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 down. And then we're going to go over, over, over. So here, when x is 1, y is negative 3. Now the point 1 comma negative 3 represents the fact that when x is equal to 1 right here, the y value is equal to 3. So this is the point 1 comma negative 3. Now, when we look at a graph, we can usually see a pattern in how the y values, the outputs, behave as we change the x values, the inputs. So in the graph to the left, we can see that as the x values increase, as we move on this graph towards the right, the y values are going to increase super fast. Okay, so you can kind of see that pattern. All right, now what happens when you're just given an equation, like a y equals something, something, x, something, something? How do you turn that into a graph? For some special functions like lines and exponentials, we've learned a few tricks. For example, when you see f of x equals 2x plus 2, you know right away that this is a straight line with a y-intercept of 2 and a slope of 2/3. To graph these, we start at the point 0, comma 2, and we would go up 2 over 3, up 2 over 3, and we get point after point after point really easily by just following the slope up 2 over 3. Now with exponentials, we also have some pretty cool tricks. If we see an equation like this, we know that it has a y-intercept of 3 and a common ratio of 2. So again, we could graph this really easily. We'd start at 0, comma 3, and then the next point would be 1, comma 6, then 2, comma 12, then 3, comma 24, then 4, comma 48. We're just going to be doubling the y value each time. All right, so let's scroll down here. For quadratics, we haven't learned any cool tricks yet on how to graph things, but that's kind of the whole point of this unit, is to learn some cool tricks to graph our quadratics. So let's start by graphing this quadratic. Here we're given this equation, f of x equals x squared. Now to graph this, I just wrote down a bunch of x values. Now you can choose any x values you want, it could be completely random, and you just try a bunch of x values, plug it into the equation, see what happens. So let's start easy. Let's plug in the 0 here. So we're going to do f of 0 equals, well, let's remind ourselves what f of x is. F of x is equal to x squared. So f of 0 is 0 squared, and 0 squared is just going to be 0. Let's do f of 1. Well, we're going to plug 1 into this equation right here. It's going to be 1. F of 2, we're going to plug 2 into the machine, and we get 4. We're going to plug 3 into the machine, square it, get 9. Plug 4, and we get 16. Now let's deal with these negatives. Let's do f of negative 1. Well, remember our equation, f of x equals x squared. So if the input is negative 1, we're going to do negative 1 squared. Well, negative 1 squared is negative 1 times negative 1. Negative times the negative is going to be a positive 1. F of negative 2 is going to be negative 2 squared. Negative 2 times negative 2 is positive 4. Negative 3 times negative 3 is positive 9. And now I've got some pretty great points. So let's start graphing these. So -3, comma 9, -2, comma 4, -1, comma 1, 0, 0. We've got 1, 1, we've got 2, 4, we've got 3, 9, and we have 4, 16. Now we can see a pretty clear pattern here. In fact, we wouldn't have to go back and graph every single point in between. We could be pretty confident that nothing unusual is going to happen between these points, that the curve is going to follow these guys really, really nicely. And we get this beautiful U shape. This shape is sometimes called a parabola. So I might use those words interchangeably, parabola and quadratic equation. Okay, so now let's go down here and talk about a little modification we might make and see how that's going to affect our equation here. So here, let's try this equation, f of x equals x squared plus 2. Let me write this out, f of x equals x squared plus 2. And the same thing, we're going to just plug a bunch of stuff in. Imagine that you've got this machine and you plug stuff in like a 0 and you get something out. And you plug something else in, you get something else. We're just going to plug a whole bunch of stuff into the machine and see how it behaves, see how it changes those inputs. So let's start with 0. F of 0 equals 0 squared plus 2. Well, 0 squared is 0, 0 plus 2 is 2. I'm going to pause the video right now, or I'll ask the substitute to kindly pause the video, and I want you to fill out all the values of this table. Okay, welcome back. So if you did this right, that's going to be 11, that's going to be 6, that's going to be 3, this is going to be 3, 6, 11, 18. And let's plot those points. Let's do this in red. -3, comma 11, it's going to be right there. -2, comma 6, -1, comma 3, 0, comma 2, 1, comma 3, 2, comma 6, 3, comma 11, and 4, comma 18, something up there. So I'm going to try to connect these really smoothly. And same on this side. And you get something like that. So what was the effect of adding 2 after squaring? See right here, we squared the x and we added 2. Go ahead and write this in. Let's pause the video, write your answer. Okay, the effect is that it raised it up by 2. It raised it up by 2 units. Okay, well, let's go and do this next one. Okay, this next one we have 2x squared. So f of x equals 2x squared. Let's try a bunch of things. F of 0 is 2, 0 squared. 0 squared is 0, 2 times 0 is going to be 0. So when x is 0, y is 0. Let's do one more before I turn it over to you. F of 1 is 2, 1 squared. 1 squared is 1, 2 times 1 is going to be 2. Okay, so let's pause the video and fill in all these values. Great, well if you did this right, 2 squared is 4, 8, 9 is 18, 16 is 32. And then we got 2, 8, 18 right there. Okay, let's see how much of these we can graph before we run out of space. -3, comma 18 is somewhere over here. -2, comma 8 is right there. -1, comma 2 is right there. And we still have the point 0, 0 like we did before. 2, comma 8, 3, comma 16. And let's try to graph this guy. Yeah, that's not the smoothest graph. You get the idea. Oh, hang on, I missed this point right here. It goes all the way down to the bottom, like that. Okay, so what was the effect of multiplying by 2? We multiplied by 2 after we squared the x, and here it just made it skinnier. It kind of made it a little bit stretched out along the y-axis. Okay, this next one right here, I want you guys to do this one on your own, so go ahead and pause the video. Okay, cool. So if you did this one right, we're going to do f of, let's do 0 equals 0 plus 2 squared. And so that's going to be 4. Let's do f of negative 1 is going to be negative 1 plus 2 squared, which is 1 squared, which is 1. So this is 4, this is 1. Let's do negative 2. F of negative 2 is equal to negative 2 plus 2 squared, which is going to be 0 squared, is going to be 0. And so I end up with something like this. Okay, so let's graph this. Negative 3, comma 1, negative 2, comma 0, then we got 1, then 4, then 9, then 16, and then we're kind of off the map here. We could go negative 4. If we plug negative 4 in, then we get up here to 4. So if we connect these dots here, we've got this kind of thing going on. All right, and so what's happened here? This has had the effect of shifting to the left by 2. Okay. Now, there is, fortunately, an easier way of doing these than just plugging in the numbers and experimenting with x values. We're going to use Desmos. But before we do that, just a little word here about terminology. Vertex is the bottom of our quadratic here. It's the bottom part of the parabola. And it's either the highest point or the lowest point. And all the ones we've done, it's been the lowest point. But you could imagine a quadratic that's kind of flipped upside down, then it would be the highest point. All right, the axis of symmetry is a line that you could fold the graph across to make it line up exactly with its opposite half. So let's do some more experiments with these guys. Let's try these ones in Desmos. So in Desmos, let's open up a new tab here. Let's go into the graphing calculator and let's type in an equation here. Let's do y equals x squared. So that's our function. We can kind of zoom in here a little bit. And you can see that the vertex is right there at that point, 0, 0. And we could even write an equation for the axis of symmetry. Axis of symmetry is going to be x equals 0. And that blue line, that's going to be our axis of symmetry. Okay, now let's go back here into our notes and see what we need to do. Let's try doing a negative x squared. I want you to pause the video right now, guys. I want you to go into Desmos, and I want you to type in underneath here y equals negative x squared. So open up your Chromebooks, open up Desmos, and pause the video until you get there. Okay, cool. Y equals negative x squared. And you notice here in this green one, it's just kind of flipped the red one upside down. It's reflected it across the x-axis. Okay, now let's go and look at our next one here. So our next one is y equals 1/2 x squared. So for this one, go ahead and plug that into Desmos. And, oh, hang on, for this one, y equals negative x squared. Let's fill in this table. So right here, the vertex is still going to be 0, 0. And the axis of symmetry is still going to be x equals 0. So go ahead and pause the video, guys. Do the same thing for y equals 1/2 x squared. Okay, so let's take a look at this one. Y equals 1/2 x squared. And the red one was our original parabola, and the purple one is the new one, and see, it's kind of flattened out. But what hasn't changed? Our vertex hasn't changed, and our axis of symmetry hasn't changed. So far, kind of boring, right? Vertex is still 0, 0. Axis of symmetry is x equals 0. And the effect of the transformation is that it's more flattened out. It's a bit fatter. Okay, next one. X minus 3 squared. So go ahead and pause the video here. And I want you to experiment with x minus 3 squared. Okay, so if you did this one, you'll notice kind of what we did before. What happened before. Here, though, it shifts it to the right. It's been shifted to the right 3 units. And skipping ahead a little bit here, if we put this as a plus, then it actually has shifted it to the left a few units. So let's add those into our notes here. X plus 3 squared, the new vertex is going to be at negative 3, 0. Axis of symmetry is x equals negative 3. And go ahead and finish this table including these ones, x squared plus 3, x squared minus 3. Okay, once you're done with that, then go ahead and answer this question, which is if you just saw the coordinates for the vertex, how could you predict the axis of symmetry? And take a look at the relationship here between the coordinates of the vertex and the equation for the axis of symmetry. Let's pause the video, let you finish that. Okay, last thing we need to talk about real quick, this is just review, hopefully should be review, is a little bit about square roots. So let's talk about square roots. So a square root asks a simple question. For example, the square root of 25 asks what two numbers multiplied together is equal to 25? The answer to this, of course, is 5. And this is helpful if you wanted to build a house that has an area of 25. You could figure out that you want to make it 5 by 5. And the square root button is very helpful if you want to have a house with an area of 26, because it's not really 5, it's going to be 5 point something. And you can find that number really quickly with the square root button of your calculator. All right, now we can write the square root of 25 as the square root of 5 squared. And the square root of 5 squared is equal to 5. Let me just write this out bigger so we don't lose the idea here. So here you notice something kind of cool. This number 2, the squaring, and this symbol, the square root symbol, they kind of undo each other. For example, if I have 5 plus 1 minus 1, I get 5, because the plus 1 and the minus 1, they undo each other. Let's say I have 5 times 2 divided by 2, it's still going to be 5, because the timesing by 2 and the dividing by 2, they undo each other. Same thing, every mathematical operation has its inverse, and the opposite of squaring, the inverse of squaring, is taking the square root. So what's the square root of x squared? The square root of x squared is just x. And this square root symbol will undo the squaring sign and just leave us with y minus 1. All right, what if we wanted to solve something like the square root of y to the 6? We're looking for something times something is y to the 6. So it's going to be y to the something, y to the something. Y times y is y squared. y squared times y squared, that's y to the fourth. What about y to the third, y to the third, and that's it. So y to the third times y to the third is y to the sixth, so we say the square root of y to the sixth is y to the third. The square root sign works to divide all the exponents in half. So if I had the square root of x to the 100, I just write x to the 50. All right, so one more cool principle about square roots is this. If I have something like the square root of 36x to the 100, I can break this apart and say the square root of 36, the square root of x to the 100, and then it's going to be 6x to the 50. So use that principle to solve this last one. Give you guys a few seconds to do that. And we should have written down square root of 25 is 5, square root of x squared is x, square root of y to the 6 is y to the third. So we've cut these exponents in half. X squared is x to the 1, x to the 6, half of 6 is 3, and 25 was 5 squared, and we turn that 5 squared into a 5, 1. So we've cut all those exponents in half. So this should help you with the homework. Speaking of the homework, it should be here in modules, and this one, 2.1 quadratic transformations. This is the homework. There's a few weird questions here that we'll talk about when I get in class. The weird questions are, where are these guys? Down here, questions 5 through 7. Yeah, questions 5 through 7 are kind of weird. Give them a try, but if they don't make any sense, we'll discuss them in class. They weren't something I thought was important enough to include in the notes for now, but we'll talk about them a bit later. Okay, good luck, guys, and have a super Tuesday.